Welcome to Spacecraft Guide, the channel that goes over the most iconic spacecraft in the world. Want to get some basic VR tours that are interactive for free like this, or like this, or like this, or like this? Well, stay to the end and we'll show you how you can do this all for free. In this issue of Spacecraft Guide, we are going to continue learning about how the space shuttle works, specifically on the reaction control system, but these are going to be on the forward jets. And the forward jets that control in outer space. So when the aerodynamic surfaces don't work anymore, that's when these jets or thrusters come into effect. And what we are work on today is the forward RCS tank isolation switches. And when you click on them, it takes you to the forward reaction control system tank isolation 1, 2, and 3, 4, 5 switch. So that is this switch right here. And basically what it's doing is it's taking fuel and oxidizers, you can see up here, and it's putting them into one manifold coming off of this side, or opening both of those for fuel and oxidizer, which come down, and actually this one line is two lines, but it goes into two different systems just below this. And here we have 3, 4, and 5, and these again are fuel and oxidizer, and that this one line is actually fuel and oxidizer going to another manifold for the thrusters, and we'll see that more. And what's happening here is these switches, they permit manual control of the corresponding pair of tank isolation valve for the reaction control system. The general computer PC position is not supported in the forward RCS. So we are in the forward RCS. This position is switch not supported. So the computer cannot move the fuel in from the switches independently, sort of like the auto mode that the computer can do it. Can't do it with the forward reaction control system. But if you put it in open, it opens the valves for the fuel and oxidizer to go to the manifolds down here to go to the thrusters. And the same on this side. If you put it to close, it totally shuts off the fuel and oxidizer right here. Now, the reason why you want to do that, you want to open it, is to use the system. But the reason why you want to close it is you want to conserve the helium and the fuel that's coming through here. Or if you have a leak, you want to make sure that you keep the whatever propellants you are using, either oxidizer or fuel, and the helium pressure, which is above that, pushing the fuel and oxidizer down. So that's we're going to get more into these valves here. We'll see that on the schematic. And if you are a free member of our Patreon, which doesn't cost anything, we're going to go into those schematics. If you are a paying subscriber, we're going to go even deeper than the schematics. But right now, for our Patreon members, if you click on schematics, test, test, test. And if you want a more detailed explanation of those lights, buttons, and switches that are in those virtual tours, well, you're just going to have to join the Space Interactive Virtual Museum at one of the paying tiers. And if you click here or you go to the page, back to the page, click on Home, you'll be able to see the tiers and what they will get for you. So if you want to join for free, which means it does not cost you anything, and you would like to get to see this, come join us on the Spacecraft Interactive Virtual Reality Museum for free, and you might even find some Easter eggs that I put in here like this.